So
Yeah.
So he's spun up and he's got the roadmap to kind of start getting stuff in his head. And I was figuring beginning of next week
sweet. That's
we
good.
can start. I can start actually assigning him things.
So what I'd like to do over the next few minutes here, and maybe JC, I'll put you on the spot because you're closer to this than I am, is going through, and Michael, if you're trying to move, I'll help you move too, is the idea here that I like to go through just the general tooling and everything that we use for API generation and stuff, schema validation stuff. Michael, obviously you'll, the stuff that's awesome that we love in this, but that, you know, Michael doesn't get to deal with in other things, right?
And it's funny because Bryce had like started rewriting this schema by hand because I didn't realize he was to that point yet. And I was like, dude, we have a generator.
Yeah.
Yeah.
Dude, I wrote like several of them, and I was like, as I'm doing it, and like, dude, there's no way that like this is the way it's done. But I was just like, I was just trying to get it done. So I'm just like, whatever, I'll just try to do it right now, just so I can move
So I told
on.
him
And he's like,
I
yeah,
told him moving forward,
like,
if it looks ridiculous, ask if we have a generator.
Yeah, that's usually the rule. If it looks retarded, not Danny, and Danny earmuffs. If it looks retarded, don't, you know, definitely like ask if it's retarded.
Hey, if it looks like a retarded, if it acts like a retarded, it's like, what is that? It looks like a duck and quacks like a duck.
yeah. I was just trying to get something done, but I was like, wow, that's makes a difference.
Yeah. No, that's good that you dove in, but yeah. So the IOTRI API schemas are actually similar to this, right? Oh no, that's probably why you did that, Bryce, right? Because the API, no, that was the conversion into that, right?
Oh, I'm confused. Were you manually updating the client-side SDK? Is that what you were doing, Bryce?
Oh,
Yeah.
oh, yeah.
Ooh.
Yeah, that's generated off the Open API schemas.
Yes. As I was doing it, I thought that they seemed kind of silly, but I was just trying to get like
yeah, it's a command line. One line, it'll do it all for you.
I was just trying to get the create and like the get done, just so I could like try and pull them through. But yeah, that makes a lot of sense.
Yeah. So actually, what I want to focus on today is the backend APIs, the SDKs for microservices. And Michael, we actually have a new version of this that makes it even more performant because you can actually do hydration within the API, within the SDK now.
Oh, nice.
Yeah, it does. Thanks to Andrew, it does the sub requests in SQL for the hydration. So you actually you basically push the entire hydrator down into SQL. So just one bulk request response, and then you're
Oh, nice.
Oh yeah.
I hope
Yeah,
a
it's
lot.
good stuff. Oh, like it totally revolutionizes performance.
yeah, that's a bottleneck and a half. We don't have too much anymore. So
Yeah, it's pretty nice. And the only thing that allows us to do that is because we follow a very strict paradigm in how we structure our databases. Otherwise, like you couldn't do it.
Yeah, so I was saying it's been a few years, but I do have a little bit of experience working. It was something Azure specific and what do you call it? Microsoft. Shoot, it's like the only thing I really forgot was the vocabulary. But in generating SDKs from a schema before, so yeah, no, I know it makes things like a hell of a lot easier.
Oh yeah. Oh yeah, it's we don't do much. In fact, we don't do anything that's not really generated anymore. Most of what we do, unless it's like one-off apps or something like in Python, anything we do in Node is pretty generated anymore.
Nice.
all right, let's dive in. Mind let me share my screen? Okay, can you guys see my screen here?
And
Okay, so Joe, just a quick introduction into our Food Forest backend API. The API is split up into two versions. There's a V1 and V2. All right, V1 is the legacy API. It's what was originally used to interface and still is used by the consumer app, right? And we have a lot of routes that are still utilized from that. Now, the work we did last year, right when COVID hit, was developing all of this inventory management, white label management, et cetera. And so that required a whole new administrative experience. And that's the bulk of what you see here in V2. All right. I'll shoot this link later, but these are the redocs that are built from our open API spec. And they go through the list of all the different resources and schemas for them. So if I reference this all the time, to be honest, even when setting up tests, I'll come back to the redocs, copy and paste from some of the examples down here. So I guess let's just go to example. You're talking about, say, a calculated group category. You can come over right here, copy an example requests body, right? And then fill in your entries on a test and go from there. So awesome resource, self-documenting, and we don't, and this thing is actually generated from the open API spec that we make. Now, I'm gonna make a mistake here, not be able to find what the actual open API.json file is. Oh no, all right, good, first try. So the file itself is just a giant JSON file, right? And I guess circling back to this particular example, if we want to say for creating a calculated group category, right? I can come over here, look up this route, calculated group categories. You can find it inside this schema because literally this is the source for this redoc UI. If you want to see it, view it a different way, you can also represent it in Swagger. It's the same source file for either representation, but all the data ends up coming here. So for calculated group categories, you've got your get, but then you're also going to end up down here. You should have a post eventually. All right, so here's your post, right? Now, one of the things, and this ties back into what Bryce was working with, this is the file that's used to generate that front-end SDK, which is one of the reasons why it's so critical that we maintain this, right? And so our workflow is set up such that this is one of the main sources of truth and is kind of treated as definitely our first-class citizen in our entire backend, because we use this this decorated field here, which is an Technicity SDK name. This ends up getting generated into that client-side SDK as a method name. And then that client-side SDK will derive TypeScript types from this open API spec, right? So you got any questions so far?
No, this sounds awesome.
All right, so that really helps out with the front-end side development. Now, this has been definitely a lot of years in the making, and it's been a team effort in getting this approach put together. We started when I started working with IOTtery back in Cardinal, we were doing a lot of pushes towards using these JSON schemas to validate our request and response bodies, particularly request bodies. We had a technique where we would compile all of them dynamically into one of these files, right? But it wasn't a structure that allowed us to reuse different schema components for certain resources across components, right? As an example, let's say you're thinking of a user, you could have a role object. There's a whole schema for what a role is. A role can have a name, it can have an enum, it has a creative field, it has its own UID, right? And if you want to define that schema there, we didn't have a good way of composing our schemas together, right? So when we move forward towards this approach, the Food Forest is really where we kind of trailblaze this new approach to building these backends. And it all starts with what are called our schema components here. So let me pull open our calculated group categories. If you look here, you can see calculated group categories up front on the schemas. Now, this is just the way this is laid out in terms of these base properties, but the convention that we had for most CRUD resources, right? Resources in which you just need at least a create route, a read route, an update route, and a delete route.
Yeah.
Are these different schemas. So we have typically the convention would be is the name of the resource for your API, right? Calculated group category. We also have a create resource, and we have an update schema. And those really are the only schemas that you need to worry about, because on the CRUD, you've got the create schema, right? And on the read, you're just going to return your main schema, right? On your updates, you might want to control the fields that are available or required, right? For example, on a create, you can require a lot of fields. On an update, you're not going to require all of them. That's where this convention on using these base properties has come in. And so the convention there is that I typically spread them out on the base category. And then on the create category, they may or may not be used. So this is an example where they're not used. In some cases they are, right? And in a lot of cases they are. And then on the updates, you can also have a lot of cases where they're used. This actually isn't a great example. Let's see if we can find another one. Interesting. Let me pull up a more modern example to get you an idea on why we end up using these base properties.
So JC, like right now, the SDK should be backward compatible, right? Because we're not using the new SDK with the hydration ability, right? So it should be backward compatible, that if we just replace the current rebuild of the generator, it should just work, right?
Well, the API for the actual SDK itself, the invocation has a couple of updates. So it's not a just, you can't just replace one import with the other.
Well, yeah, but I'm talking about the actual API itself, like through the rest of the route handlers and everything.
Yeah, I mean, our overall approach has not changed by any means.
That's what I thought. It's just added ability. So
exactly, and you can take a hybrid approach. We have, for example, Armadillo right now. I haven't removed all references to the old SDK, so it has a mixture of the two. So they can be used inline, and the new SDK can be used additively. So nice. If we find a case where we need to improve performance, right, we can bring that in, and it doesn't cause, it's not one or the other. They're not mutually exclusive.
Cool, good stuff. So anyways, the reason I mentioned that is because Michael, Joe, you may want to bring the new one in now, so you can start using the added hydration ability of the new thing, particularly if you're starting to see performance issues because of scale. You can actually change out a lot of the manual hydration with that API in certain points, because that's basically what we do, right, JC? Like we'll write like just the dumb non-hydration first, and then if it becomes a sticking point performance-wise, we'll just go through and then rewrite it to use the hydration of the SDK.
Exactly, and the only difference that you have to have is we change from hydrators to loaders. And loaders essentially just describe the field names that are associated, and you can nest them just like you can hydrators, right? So those, if the only work that you would have, if you, let's say you're going to switch to a resource that has a lot of sub resources associated with it, you're going to have to go through the work of writing the loaders for each of those sub resources too, just like with hydrators, right? So it does pay to start with the new one, but it's not, it's really not that painful. And once we're going to keep walking through this schema approach, and you'll see where this starts to pay off, because one of the issues was not only just having this absence of reusability between components, but it was also the fact that the hydrators themselves were manually written and they weren't driven from the schemas, right? And so you'll see here in a moment that the hydrators themselves also use these property fields from the schemas in order to figure out what fields to select from the table, since we don't expose every single field from our tables either. Right. And we'll get to that in a second. I just want to show a pretty clear example of our I'd say latest and greatest convention, right? And so here's an address resource. Everybody knows what an address is. You've got your street name, city, state, et cetera, right? The base schema has all the things that you would expect in an address, postal code, and country as well. And then our UID in a created field. Now, if you go to where this thing should be updated, you can see we allow them to update any of the properties. You can update your streets, your cities, your states, et cetera. What can't you update? You can't update, you're not going to update your UID, you're not going to update your created field. That's why those get left out of your base properties. All right. So that's kind of, you got to think about in terms of, if you were to think of the Venn diagram of the 3 different types of schema components that you would have for a given resource, be it the base one, the update, or the create, what fields are going to need to be common across all of them. That's what goes in your base properties. And then I guess if you look down here for create, the biggest difference between update and create really is just what's required, right? So in this case, we are requiring that all of the base property fields be present, right? Now, we've got a couple of updates that are in now that say if a field is nullable, then we actually exclude it from that list. And I can send you the code that does that. That's one thing that we'd like to move forward towards. But with the exception of that, it'll drive the key names here and automatically make those required, right? But if you look at the update, you get to choose what you want to update, so you don't have to require any of those, right? That's a common convention. Now, getting back over to Food Forest, when you look at a particular route, let's go back into the perspective of calculated group categories. If we look at routes for that here under admin, we usually always end up having 4 different files in here, and we separate this into the index file that describes the actual route names, right? This gives us all of our CRUD routes along with the middleware. And then if you notice here as part of the middleware, we're bringing in these schemas, right? So what I just showed you were component schemas, right? But we use those component schemas to define the request and the response schemas. And we do that in the schemas file for each of the main resources, right? So we've got a schema for getting a list of the records. And in this case, you can see that it uses that particular base component as the response schema, right? There's no request on a get or request body on a get. On a post, you can see here, part of the initial part up here is the request. So we have our request create, right? And then response, it's the base category. And what that allows us to do is to, 1, reuse them. 2, it also separates the concerns. So there could be some cases where you have routes that don't use a component, and maybe it may be so unique that there's no point in going through the boilerplate of making a separate component just for that. So you have the flexibility if you want to. I'm sorry, what's that?
No, I was saying okay.
Yeah, so you have the flexibility if you want to actually define the schema inline here, right? So if you wanted to, you can literally just start type object, right? Put out your properties, and then start lining up all your properties, make up your required field. And there are some cases where you'll notice in the code base that that's done. There's nothing wrong with it. If you're not going to use it again, no need in having extra layers.
Right.
And
it's
so,
all about reuse, right? Object-oriented programming,
Yeah.
reuse, that type of thing. Stuff we're all used to if we've been doing software for a while, right?
Yeah. Oh, this is getting me excited. I like this.
Careful, Joe. Careful.
Guys, watch out, Joe's 3/4 chub.
I think his video's not working.
so
Yeah, right.
Now I see why he's not turning his video on. Okay, thanks, Joe. We respect that.
Yeah, I thank you as well. Okay, so those components, those end up defining essentially request and response bodies, but we also schema, not only do we schema our request and response bodies, right? But we also need to schema the route name or the route path, and we also want to schema our query parameters. And that's where this parameters field on the request comes in. So in this schemas file, you'll notice here's a field. This is calculated group category UID. And that's in the path. So when it's in the path, that's equivalent to it being in the route name. If we look at this specific one, patch 1, you'll see it's right here. So it needs to match up with these route parameter names, right? And the other thing that you'll see is you'll actually notice some of them are specified in query. So this will schema, and that's how this actually all gets generated. This all comes back to these automatically created docs. If I look at this get list, you can see here a list of, let me see. All right, these are a list of query parameters, and you can see the options. So you can query it as a string, or you can actually do a like, right? And that's equivalent to a like call in SQL. And we have also have libraries that go in and generate these lists from the properties and the schemas, so that you don't have to manually type out your filter query parameters every single time you make a new resource. But you could have, for example, maybe you have a search query parameter and you need some kind of unique treatment. That wouldn't be something that's a field in your resource. Then you can come in here and manually add it. And I guess just to take you back to one of our latest examples on that. If I come down here into addresses, you'll notice we have a get filter query param list. This will use, for example, that base address resource. It'll go through its entire properties list and it'll create these structured query parameters just based off of those properties, right? And so that's back to like literally everything is driven by the schema, right? We start, like whenever I'm going to add new routes, I start in components, then I go and add the routes, right? And I then at that point, I'll adjust the schemas file, right? And you do whatever kind of adjustments you need to do in the handlers, and the handlers are, as you might expect, they're the route handlers, right? And so you'll have your and for your typical CRUD, your get list, you've got your post. In some of these cases, you're going to be posting a link to a different table. Maybe in this case, you've got an inventory item category UID that's coming off of the request body. When that gets posted, you need to verify that it exists, right? And so a lot of times in the route handlers, we'll do those kind of confirmations. But other than that, this ends up going all the way to the point where we are using the SDK to create the resource. And then this case here, creating a calculated item is a little bit more complicated than just a simple post because there's a lot of dependencies. And so I guess here's an example of an actual DB service post, right? This is using the SDK. Some of these have a lot of other dependencies. So we'll create sub libraries and then you can dig down for that particular resource. But what you will see in Food Forest backend at the end of the day is everything gets passed through a hydrator before it gets passed back, right? And that's done by convention. And so the idea with the hydrator, come up here, we can find a hydrator for each of these types of resources, a hydrate calculated group category, for example. And this will, if you look up here, this will actually pull the schemas, right? And when it goes and picks stuff off of the resource after it grabs it from the database, it will pluck the properties from the schema off. And then the only thing that you have to do afterwards in this hydrator is add these extra hydrated items, things that aren't directly available in the table. Now the SDK will do one really convenient thing for you. If you have a link table to another resource, right, be it an inventory item category, for example, you can automatically, it'll give you the UID. So you're not going to have to go and do that join and figure out what that UID is. It will get that for you. What it won't do is actually get the whole resource, right? And in that case, a lot of times when you have schemas that are composed, I'll see if I can find, let's look through these components and see if we have any schemas that end up actually being composed. You'll see a reference to another schema in here.
Not sure if we have any.
We don't?
Yeah, you're looking for like a ref or something in there?
Yeah.
Like inside of an object? Yeah, we may not have many of those in here. Maybe in pagination. I think we have a ref inside of pagination for the parameters.
Well, I'll take you guys back to one of our more late recent repositories. So here.
I think we still had issues when we were setting that all up.
Yeah, we've done a lot of work on that Open API library too, since then too.
Actually, it wouldn't be a bad thing to check out. I'll go to horror real quick.
Some of this is even new to me.
Everything's new to you, Danny. First time, every time.
And nothing I'm showing you guys right now is stuff that's not available to Food Forest.
Beauty of innocence, Danny. Hang on to that.
All right. So in some cases, you're going to have, this is an example of a base schema component. And so in some cases, you're going to have a link, like for example, this table here happened to have a user ID. Like I said, the SDK is going to get that user UID for you, since we never expose IDs through the API, right? So it's going to go in, it's going to link and get that user UID. And instead of just responding with the user UID, you may also want to hydrate the user onto that resource. And in that case, you can use refs, right? So this is the syntax for actually referencing another schema. And that's how we can get in there and start actually composing these different schemas together. When you do that, these are the kind of things that require a little bit more manual intervention inside of the hydrator. You're going to actually have to go in there. And for example, you'd have to go into the hydrator for this resource, add a GET request for that user based off the user UID that you have. But then what you would do is you would actually get the hydrator for the user, import it into this hydrator, and use it to hydrate the user object, right? And in that way you get reuse. And so you know that for a given schema, you only ever need to define the way it's hydrated in one location. And we enforce that. So not only do we capture schema integrity via convention, but we also have a part of our library that I guess consumes all of these different schemas, because I'm not sure if you noticed, but inside of this index file, there's this OAPI object here, and that's where the schemas go into. So this is an overall library that we modified a little bit for our use case, and it is what ends up generating those redocs. It is what compiles everything down to our open API spec, right? And we've also integrated validation into it itself. And so it will not only do request validation, but we can also make it do response validation. And you might ask, well, why would you want to crash your own server? Well, it's like, well, you want to keep yourself honest, right? And so if we know that we're validating our response schemas, that allows us to quickly capture anytime we violate that. And that's important because if the front end SDK that's generated from the open API spec can't trust, it won't be able to trust its own TypeScript types if it can't trust on the server to send back the correct response body.
Right? I will mention here that we typically turn off response validation in production because it is a performance hit, particularly on really large objects, right? I mean, right. If we know that we have small objects, then we'll leave it on. But for things like this, where you might have, tons of paging or whatever, we'll typically turn the response validation off, because we know that by the time it reaches production, you better be validating your responses.
So that's the overall brain dump on our schema approach, right? And I think the rest of the details you kind of get familiar with by doing it. But if you end up with any questions, or if you feel like you're, not staying dry enough, then just hit me up.
Yeah, that was a solid dump, JC. Very nice.
I was gonna say, real solid, not too runny. Sorry, that couldn't help it.
Fortunately, the bidet, it should be a quick fix there. So good stuff.
Absolutely. I was gonna say, this is starting to, speaking of full circle, it's almost starting to look like you guys are bringing the Java into the JavaScript.
Almost. We don't go quite that far. We don't quite go that far, and I never intend to go that far.
I was gonna say, I don't see like decorators or anything on any of these yet.
We do a lot of TypeScript, so you have typing.
Oh, I love TypeScript.
But no, so there's TypeScript all the way through this, you don't see it here because some of the especially on this OAPI stuff, because it wasn't written in TypeScript. But most of the things we do, we use TypeScript for.
Yeah, a lot of the handlers, depending upon the backend, like a lot of these handlers, for example, on these later backends, they're all TypeScript. And the reason that you're going to actually make your handler a TypeScript file is because then if you don't, you won't get the type completion from the SDK, right? And you know how it is. You always want to catch stuff compile time before runtime. It's faster.
Oh, absolutely. And I'll admit, based on my background, strongly typed anything or something even approaching that always makes me a little happier. Even if
Yeah.
it's TypeScript and it's kind of in a gray zone.
Yeah. So one of the things that I'll mention is where we were talking about the field stuff for the hydration, where you push the hydration into the SDK. Do you have an example of that, JC?
Yeah, like we can look at how it's done on
HAR or something. There we go.
So
Yeah.
so you've got these hydrators, right? These are like your old classic hydrators where you'd maybe you've got your user hydrator. For example, this is a really simple one. Here's like a base hydrator, and this is what it looks like. It's just a single function. You pass in a record. You can pass in either the UID of the record or the record, a raw record itself, what you get back from just a single SQL query. And then if it's a UID, it'll actually go in and it'll use the SDK to get the role. This is all old SDK. And then I'm going to walk you to what it'll look like with the loader. All right. So this would get it from SQL. And then it uses that properties field from the role schema in order to prune the record. Right. And that's kind of what we're doing. We never want to expose fields that aren't included in our schema. And so we do it in a way that all of our schemas have to be additive, where you have to explicitly state what fields you're going to include. Now, this hydrator, you can see, is driven by the schema. So if I add a field to role, it will show up here in this out, right? The thing that you have to start nesting is when you start including or composing your schemas. Now, for a loader, let's look at the assumptions loader. It's pretty bare bones too. All right, it's similar. We use this get scalar keys function, and what that does is that goes and looks at the schema itself, and then it will pluck out any keys that happen to be fields that are composed of other schemas. So a field that would be an object is very likely a different schema, and any of the fields that are primitive types, namely strings, booleans, integers, you have it, right? All your primitive types, that's the only list that comes out here in the scalar key list. And then what the SDK takes in when you send out the request is it takes in a list of keys, right? And initially, if they're fields that exist directly on the table, those lists of keys will just be a list of strings. If they are linked resources, and that gets back to what BJ said about the convention we use on how we build our data models. The convention, for example, you might have a many-to-many relationship. Maybe you have an organization and then you have an address, right? And maybe you want, for some reason, maybe you've got like 3 different organizations in the same building, and then that organization also has an address in another building. You want to be able to share those things. So you could use an organization address link table, right? And we have a typical naming convention where our naming convention is you use one table name on one side, another table name on the other, right? And create links between them, ultimately flexible. Those kind of conventions are baked into assumptions for this SDK. And that's how you can actually use, instead of just a list of keys, which are just strings, you would list sub-objects that actually define, the name of the thing that you're trying to.
Hey, Jason, can you actually show the data model to give an example? Because I think that's
critical.
That was a good description, but I want to make it real clear here, because I'm recording this, so all of our talks about big dumps and stuff is going to be great, because we're going to show this to everyone else.
All right, let's see what user links we have, because that's always.
You're gonna leak it to CNN.
I'm going to leak it. Yeah.
Yeah.
Yeah, exactly.
Well, you know what? Every single one of these fields ends up having a project ID, but I want to get an example of a genuine.
Go to like the user. Can you bring up? Yeah, just do a user role, like real standard. Yeah.
So we have a user table, right? This is our user table. standard stuff, first, last name, email, etc. Right? We also have a role table, so where we specify, standard user, super user, etc. And that's all data driven. We have it set up so that a user isn't constrained to just one role. They can wear many hats. So we have a link table, which allows us a user role table, gives us a many to many relationship, right? So that is simply at the bare bones level, just a link table that links you to a foreign key constraint on your user ID and a foreign key constraint on your role ID.
Yep.
Right.
So that makes sense.
Yeah.
Pretty standard.
Right. So you can imagine on a user resource, you might want to have a list of roles that are associated with that user. And if you were to bake that all the way down to SQL and say, okay, well, select star from role, where ID in, and then you'd have another sub request saying, select role ID from user role where user ID equals escape question mark, right? And the way we do that through the SDK, let's come up here to I'd say that users. All right, so this is an example of how we would hydrate the roles list, and so you've already seen a simple example of a loader where you're just grabbing the fields right off of the component schema. In this case, we also want to specify how to get that role list. Now, I want to take you first to the component because you always start with the component. And if you look here, you're going to see on the base user schema, there is a role list. Now, it's not just a simple ref because it's an array of these roles, right? So it's going to be of type array where the items in the array happen to be that role schema. That has to be defined in order for this to work, but you have to do it in two places, right? Because unfortunately, it's not automated to the point where you could just add that to the schema and then it automatically comes through a load. That would be pretty incredible. But it is flexible enough where you add it here, and then the next place you would either add it would be depending upon what SDK you're using in the hydrator or in the loader, right? If you're using the latest SDK, that goes into a loader. And so what you do there is you also on that fields list that you're looking for, you say, okay, I want a role list. And then you can see here, this is where that nesting comes in. So I have roles has its own loader. And so for the fields for that, then I use the role loader to get its fields list, right? And then you can also provide filter arguments where you want only ones where a valid flag's true, because we don't delete anything in our databases. We just set invalid, right? I would set valid to false.
Yep.
You
Never
can also,
delete anything unless you really mean to, which is very rare. Ever. Don't delete shit.
and then I guess let's look at where this is actually invoked, right? That would be helpful. So it finally gets invoked when you look in a handler. And so you could imagine you could get this for a login. So you come into your login, provide your username, email, password, and then at the very end of it, let's see here. Now this guy's still using a hydrator. Let's go back to assumptions. So you can see when you go to create an assumption here, just another resource, right? You can imagine the same way you'd imagine with a loader or with a user. This fields field here, which is the second part of the SDK, that's what gets that that first root level of your gets fields list, right? And then as you can compose these loaders, just like you do with the hydrators, it's going to keep loading the proper fields for any of the sub resources.
Yeah, and there's a significant performance reason for this, right? Because actually what's going on underneath the hood is what's being constructed, thanks to Andrew, is a bunch of joins, SQL joins, which are more efficient than, of course, sub-select queries, and of course, obviously, a bunch of separate TCP ODBC calls, right?
Well, it's not joins, but there's a lot more batching.
Okay, batching and stuff like that.
Requests, so, yeah.
Right. So there's a significant amount. There was some joins in there, right, Andrew? I thought there were some joins, but
I have to move away from that because it's messing up with the pagination.
oh, that's right. That's right. The joins really end up. Yeah, never mind. Anyways, it's still very, it's a lot more efficient than trying to manage it at the application layer, right?
Yeah. And that's another perk that Andrew just mentioned that we didn't even touch on yet. These SDKs are awesome because they implement all the details that you need for pagination already. So if you look on our like get list queries, there's a set of libraries here, but when you look at what you need to do to paginate, you almost don't, honestly, you don't even need to think about it unless you have a unique use case, and then you actually have to go into the weeds of actually setting up a pagination. Right now, all of our pagination is almost exclusively cursor-based pagination. And you can specify, essentially, you get to specify by default, typically the size of your pages, so how many resources you want. It'll provide back a base 64 encoded cursor. So you provide a direction. Do you want it ascending or descending? We don't have it set up right now where the user gets to select what field is used to control what to order by, right? That can easily be brought in use cases where that's important. But right now we either usually go by the specific ID to order, or we go by a created date. And then you can, we usually go forward. So almost exclusively, you're going to use an after cursor. That's just by default. But if you do fall within that use case, which is the majority of them so far, then you can just essentially follow our pattern here, where you pass in the request object. It will, this get paginate query will pluck off the relevant information. We also, by convention, add those after limit and order query parameters to all of our schemas. If you look in here in the schemas itself, and this list here that comes in and actually defines on a get list what parameters are associated with it, it will bake in those pagination, right? This right here, this pagination query parameter list, that's always in almost all of them, right? Now, let's get back here. This paginate object actually gets passed down into the schema. And then so the schema itself will provide the information that you need in order to pass back a paging object. And if you look here at the schema for a paging object, it includes the total count, right? So maybe you know that, all right, there's 1 million resources for this request, but I'm only looking at 200 at a time. Here's my after cursor, and it will also provide a previous and next link. Like I said, we almost always use after. So before is a little bit less tested.
Yep. So very, should be pretty easy, very pattern based at this point. Even putting new tables in, right? As long as you follow our paradigm, this all will just kind of work. It just works, right? Register trademark. Yeah, right. The big place that I would look at, starting to look at performance, is within hydrators. Going back to Food Forest, that whole folder that JC was showing about hydrators, that's where a lot of these loaders can start to be used and leveraged. So if you run into performance issues, that's where to go and look at. The primary thing, Joe, is talk to Michael about features, because we really want new features to be implemented, but in the process of that, veer off sometimes to fix performance things too, as we go, that kind of thing.
And if you want some quick wins, on getting used to this hydrator, getting used to the loaders, look for schemas that don't have a lot of sub schemas, right? So if you find some schemas, particularly ones that don't have so many fields either, right? And then like that address example that I had up here, if you can find some resources like that within Food Forest, that would be a good place to start if you want to get your hands dirty on how to make the migration, and you wouldn't have to deal with the complexity of having to make 10 different loaders just because you started with a high level schema.
Okay.
So, yep, that's the news. So lots of really good stuff here. Any questions?
Did you guys walk? Oh, go ahead.
I said 1 million, but I'll space them out.
All right, cool. What was that, Andrew?
Did you guys already walk through like how to regenerate the SDK and stuff?
Not yet. That's probably the big one here that we should probably do.
Just a
Oh
quick
yeah, that's a good
question,
call.
JC.
Yeah, let's look at that here.
Our local village idiot has a question, I think.
Oh, sorry, go ahead.
Sorry, maybe I missed this. The loaders, when they're when they're generating the stuff based off the fields, is that the fields from the schema or the fields from the tables in the data model?
They're the fields from the schema, right?
Okay.
Where
All right.
where the schema has to be congruent with the data model.
Yep. Okay. I just want to make sure.
Yep. Unfortunately, there's no such thing as magic elves, right, JC?
Yeah, you got it. And to the point, it's a good separation to have because we don't always do a one-to-one mapping between our
Right.
data model and schemas. Like
it's pretty rare that you do, because there's security as well as just unnecessary information, right? That doesn't mean anything to a client, an API client.
exactly. So there are things. A perfect example of a separation between API and data model, where the data model sort of became an implementation detail, is when we were looking at sorting different resources within the UI. So if you look at the item category carousels, you might have like apples and carrots and a bunch of other items, and maybe you want to shove the grapes up to the front, right? Well, in order for that to be captured inside of the database, we have to keep track of it an ordinal value, right? Is it number one? Is it number two? Is it number three? Instead of making the UI deal with the complexity, the API the idea is to design the API to allow the UI to do exactly what it wants. And that's, all right, I have, maybe I have apples and bananas and I will put grapes at the front. I just want to take the UID from the grapes and I want to say, I want to insert that in before the UID of apples, right? And if I pass that type of intent onto the back end, it should handle all the details about reordering, right? And so that's what we've done. I'm not sure, maybe that's even captured here. It should be. Andrew, do you know off the top of your head where that's located?
Sorry, what was the question?
You remember the reordering routes that we defined? I don't recall what resource that actually is for. Here we go. Reorder.
Yeah, so that's like a rebalance, right, of all of the ordinal magic, right?
Yeah, and so if you think about it this way, the front end doesn't have to worry at all about the actual ordinal numbers, how the sort's being done. We could do it in a linked list, we could do it however we want, but the API is designed such that you provide a UID that you want to insert before, and then you have a list of UIDs that you want to insert before that.
Yeah.
Right.
Yeah.
And then
and that's so we can abstract the implementation details, right? Which we may need to change at some point later down the road.
Yeah, if we run into scalability issues, et cetera. And so that's just one of the further arguments as to why we do keep that layer of separation. We don't just do a direct mapping from the data model straight to the API. Unfortunately, it's an extra layer that we have to maintain.
Yeah. Well, it also defines your business, right? Like these schemas are going off on a kind of a rat hole here, but in terms of paradigm and philosophy, but the schemas, you should be defining yourself, right? Just like you need to define your data model, you need to define your schemas, because your schemas are what define your business value and your application. No one can do that. A machine can't do that, right? And
yeah, you got to define the interface, right?
And if someone has a machine that does that, let me know, because we'll all just retire right now. It's called AI, right? It's going to be the answer to everything.
I thought that's what Futrell was for.
Yeah, right.
Predicting what schemas are going to be relevant in the next 3 to 5 minutes.
Yes, predicting the future. Cool.
We want to talk a little bit about generating these guys.
Yeah, let's go through the generating, and then we'll call it a day here.
All right. So this guy actually gets pulled in.
But before you do that, have we added the new loader and stuff to and set up to the template, the gateway template?
Not yet.
Okay, we should do that.
Yeah, we need to update that. So this is the legacy SDK, right? And it gets installed into node modules. All right, so it actually, this is a little bit different of a setup. Our current setup is a mono repo, right? This is still a separate repo for the actual SDK. Let me see if I have that pulled down here. Yeah, backend API. So the code in here, this is a separate repo. This one here is auto-generated. All right. Let me actually open this all the way up to just the food forest level. All right, so what I just showed you guys was the gateway for food forest, which includes both V1 and V2 routes. And then this backend API repository is that SDK. All right. And it was, I believe we're using direct, aren't we?
Yes.
Pretty sure that's what I just saw. So that's another thing to note is with the legacy SDK, there's two ways to use it. One way is we actually spin up a microservice that's a full-on REST API that the SDK maps to, and then that REST API connects into our SQL database. There's also direct where we bypass that whole route, which is what we've done here, and the SDK calls map directly to SQL calls. All right, so we just took out the microservice completely and we go direct to SQL. That's why it's called direct SDK. But that being said, it's still the same code base that gets generated. And if you look into any of these generated legacy SDKs, you'll find a update service script. And you simply need to execute this script while providing your SQL database username, password, host, and port. All right. A lot of times you don't have to specify host and port. You can provide username and password if your SQL instance is running on your development machine, right? Now, where this gets a little bit more tricky is a lot of times we might run SQL up in a Docker container. And so if you're doing that, depends on where you execute this script from. If you execute it within the Docker Compose environment, then you have to be cognizant of knowing that, for example, the host name for whatever your Docker or whatever your MySQL container is depends on what you call the service name. A lot of times we just call it MySQL, right? If you're executing this from outside of a container and you just have simply, you're like, I don't want to install MySQL, I just want to run in a container. You can do that. Your host would be your local host or 127.0.0.1. And at that point, you have to use whatever port you are publishing from within your container. So a lot of times 3306, you probably won't publish a 3306, especially if you have MySQL running on your machine, because you're not going to be able to get this spin up. It'll have a port conflict, right? So you just know how to access MySQL from whatever environment that you're executing the script from, right? And that might be a little, I guess we can clarify that a bit. Joe, did you get set up on the development environment? I'm sure that you've seen that we've got all this.
Yeah, he's up and running.
Okay, cool. So you know the craziness that we do now with just all Dockerized development environments. You actually go into the container to develop, but the big thing to know is that development container gets a bind mount to the actual workspace that you're in. So there's a hard link in there between the file system on your host machine and the container itself. So when you're in the container, you get to access that file system. What that does is that gives flexibility. Do you want to run these kind of commands outside of it, or do you want to run them within it? In order to run this update service, you actually need to have a microservice generator installed on whatever machine you run it from, either in the container or outside the container. And we can provide you the credentials because this is a Technicity specific NPM package. All right.
Okay.
You need an NPM token for that.
Right. So you'll just have to do a login with NPM to be able to install it, but it's a typical global install, just like you would do with any other package that's public. Once that's installed, then you just run this update service. If you are generating a legacy service from scratch, which I don't think we would do now because we have the new SDK, then there's another set of command line conventions to follow. But just to give you a little bit of theoretical background on what this thing's doing, and Andrew, please correct me if I'm wrong on anything I say here, is this will actually connect up to SQL. You have to provide what database you're looking at, right? So this could be the food forest database, and it will introspectively examine that database, look at the tables, look at the fields, and then generate the SDK from those. Which means is when you go and you update your data model schema, you got to remember to apply it before you can actually update your SDK.
Yeah. So
Right.
So I'll say that again because this is really critical. You have to have the thing that you intend to generate the data model you intend to generate has to be loaded into MySQL because it's introspective. It actually goes in and will look at the existing database, running database, the running actual MySQL database, and run all the queries on it in order to get the current schemas. And that's how it generates it.
And that's exactly why you have to provide all your credentials and a location for SQLs, because it needs those to be able to access that info.
Do you have an example of that command, JC? I think it's like node, it's node update service.
Yeah, I mean, it would be right. If I were to go into here into the backend API, it would be node update service, and then you just look through the list here, it'd be like root, maybe the password is just password, right? Host,
yeah, and
I'd
then like
food,
yeah, and then food forest, the database table name, port, and the database name, right?
I think. Well, so what happens here is the.
Oh, that's an update. It's already.
No, this is hard baked in. So yeah. I believe that's in. It's somewhere in here.
Yeah, so you don't have to worry about creating a new one, which is only done once. You just have to worry about the update service because it's already created.
Yeah, you don't actually have to go through that portion.
Wait, so this is the old one.
Yeah, here it is.
Does this, Andrew, JC, does this change now that with the new loader SDK? I don't think it changes at all, right?
Well, no, it actually does. So you
okay.
you by convention right now, you end up writing your own regen script. So if you look at the latest here, we actually have a gen script. For example, I just put this together. It's simple. You, as the generator script, you have to install the data service generator. That's our latest and greatest SDK, right? And upon that, you got to provide your credentials, right? As well as your database. You provide an output directory. So this is where the actual SDK is going to be written to. And then it'll just generate, right? But it is, when you see this require global in here, it's going to assume that you have this data service generator installed. But other than that, this is fairly boilerplate. The thing that really, the parameters that got to be adjusted, I can just send you a copy of this gen SDK file, have to be here. If you prefer to bring them in from the command line and type them out, you can do that. If you want to put them in environment variables, you can do that. However you want to map it, it's your choice.
I mean, this is better because then it's just you remember one script, right, and then run it and bake it in.
Yeah, I just run it this way. Yeah, so and I don't forget what the port is or anything because I don't have to remember it.
Yeah.
Obviously, if we had multiple people working and then multiple people setting up their, like if we didn't unify our SQL servers, then yeah, we would probably shove the host and port out to an environment variable and say, right. Okay, set up your local environment and then I'll set up mine so that we're not ending up with merge conflicts.
Right.
But
yeah, let's get you set up with this new SDK so that we can start. You can use the loaders if you need to on Food Forest. All right, so that's how you actually generate, or that's how you update / generate. How does the import change then?
So the import here, it's still in services. All right, this is where it gets compiled to. You can see all the SDK TS, right? And then the import is pretty short and sweet. The original import looks like this, where you grab the SDK, right, from DB service, provide your credentials so it can connect to SQL, specify a logging mode if you want, maybe you need to debug. And the new import, you also import the SDK, import the config. For driver options is where you provide your SQL. I don't have any debugs here, but if I want to, I can put COM query packets or row data packets, etc. That's if you want to see, if you're doing it that way, if you want it to log to the console and you want to see standard outs of like the actual SQL queries being submitted, that's where you go into it. I mean, that's like a low level bug if you got to the point where you got to look at that. So that's very rare. And then also that's really cool is we can select dialect. How many dialects do we have now?
It's only MySQL. Yeah.
That's gonna change very soon here because we're gonna have to switch to MS SQL, which we're gonna be talking about at 4 p.m. today. So we'll have to do an MS SQL here.
we've at least earmarked dialect to being, a flag that we can just swap back and forth between, which is amazing because then if you don't need any super special treatment, I mean, you could not know hardly anything about a different dialect and then just use the SDK.
Yep. That's what SQL was supposed to be, right? But then it became not.
Yeah, I mean, invariably, there's some applications where you got to dive down into the actual SQL grammar itself, right,
Now,
to make certain things happen. But those are the exception.
Now, keep in mind, like, we use very, very little of SQL because there's a whole world of SQL in there where you can do procedures, views, all those different things that are very dialect specific. We try to avoid all of those as much as possible. We only do those if you absolutely have a performance thing that you absolutely have to push down. And it doesn't preclude this, right? Like, you can build those things into this SDK. We don't right now, but we can, and we may have to for larger things like some of those healthcare revenue cycle things or whatever, right? Maybe in the future. MS SQL is a very non-performant sort of thing, so they tend to just automatically write views and procedures. That's kind of the traditional way to do things. We're going to see if we can avoid that for as long as possible, but just I wanted to mention that because we may have to do those types of things from a dialect perspective. That's a conversation for another day, though. But yeah, so anyways, you'll see that these are two SDKs running side by side, right? So you'll import the new SDK, and if you need the loaders, then just import the DB service v2, and you don't have to replace anything else from there. The downside, of course, is that you have to regenerate both, right? If you make any data model updates.
Right.
So the idea would be to replace all of them if you can, but and there's no breaking changes in our data service generator, as far as I know. Is there any breaking changes? I don't think so.
What do you mean by breaking changes?
Breaking changes in that if you were to remove dbservice.ts, right, that you could just replace all the underlying API with the v2 generator and then just add loaders.
You'd have to replace all of the invocations to the service side. That's why I wouldn't say that they're
Okay.
not. Yeah, they're not. It's not backwards compatible.
Well, you only have to do it at the service level, right? In the invocations. No, I guess that's not true.
Yeah, but that's every single route handler.
Yeah, that is because show an example of the invocation, JC.
Yeah. So
here's a route handler structured like this.
This is probably a good one. So if for registering a user, I believe I use the old SDK. Yeah, this is the old SDK.
Right there. Yeah.
And so you got a post user, right? It's pretty close. There are some cases, like for example, a difference is, I don't know if this is added, but right now we don't, I believe we don't allow you to specify a UID exactly, right? Because what this is doing under the hood is this actually mapping that UID back to the ID.
Right.
But if in the SDK v2, these are just IDs, right? So one of the primary goals with SDK v2 was to get more performance back, right? So if we can avoid, if we don't have to do a UID lookup, we're not going to, right? That's one thing that would be incompatible. Another thing to look at would be, I'd have to find an example of a patch. Let's see if we can look in here and find a patch. There, patch order, right? So this API for patch order on the legacy SDK, you provide the UID of the resource you're trying to update, and then you provide fields to be updated, right? And in the latest SDK, that's actually split up into two arguments. You don't bake the UID into the same object that you add for the updates, right? And so on the latest SDK, if I want to update a particular resource, I will actually, that's a little bit more complicated example. Let's get something simple. So I will come down here, and then when I patch it, you provide the UID as your first argument inside of an object, and then you have a second data object, right? And then you see the fields here. So those are some of the incompatibilities, right? Secondly, there is no fields object for the legacy SDK, right? And you'll notice all of the legacy SDK are using this correlation ID, and that's for when you use it as a microservice so that you can correlate a lot of different requests into one transaction. And the other thing that you'll see as a pattern for any of our old SDK calls are the hydrators. So you get the raw response back, then you pass in your raw response into a hydrator, and that gives you a hydrated response that needs to be compatible with the response schema defined from those route schemas, right? Which ultimately, for the most part, are composed of the components that you define.
Another difference is in the new SDK, like the list methods, they're split up into paginated and non-paginated methods. Because the old one kind of had a hack where like I attached like the pagination properties onto the array. And it was like harder to type check and stuff.
That was a bastardization of the JavaScript language right there. Everything's an object.
I forgot about that. So on the Git lists, or almost by convention now, or if you got a Git list, it's paginated, right? Now, how do we avoid somebody getting a list of resources that they shouldn't have access to? Well, by convention, you also need to access the calling user ID, right? So this would be whatever user is actually hitting that route, and provide the necessary scoping in order to reduce the scope of what gets returned. Right. So in this case, right, this user is getting a list of guide words, and we want to say, well, we do some denormalization on our SQL database where we make sure that, for example, in this case, everything is associated with a project, right? That's like one of our main high level resources. And so I just need to track, for example, what projects a user is associated with. So any sub resources within that, I'm going to go ahead and denormalize and add that project ID. Why? It just makes your life simpler when you've got a query. You don't have to go through maybe 10 different resources that are normalized to get back up to a project. It's worth the extra disk space, right? And so what you would do there, we just simply come in here. There's a project member table. You look up what projects that user is associated with, and then you map it down to a list of project IDs. And then you just make sure when that SQL statement gets executed, knowing that, for example, a guide list has, in this case, a project ID associated with it, you say, okay, select star from guide word where, and then one of your wheres is going to say project ID in, and then you provide an array of those IDs, right? That's just an example. It all depends on the, your data model and what it is that you're trying to return. You just got to think about, what are the minimum resources that I should return back to this specific user? And I think you can naturally get there once you get familiar with the data model as what that means.
Yep. Cool. So what do you think?
Well, a lot of information, but no, it sounds pretty cool.
Nice. So
Looking forward to diving in.
Cool. So I recorded this. I will post it and give you guys links to it, so that if you want to watch it again, or we can also share it with others. It'll be good to go.
Excellent.
Sweet. So that's the deal. I would keep talking to Michael about what the next steps are, but you got some work ahead of you.
Awesome.
Cool. Good stuff. I guess I'll talk to you guys again at 4 p.m.
Sounds good.
All right, guys.
Later.
See ya.
Yeah.